Okay, good morning, everybody. First up, thank you. Yeah, I saw I was against Richard on the first floor and thought I'm going to be in front of an empty room today. So that's awesome. Thank you so much. So testing first. We've all seen the stories that this is the way to go. That if you do this, your code is going to be amazing. Your life is going to be so much better. And when the clickers work, things do good things. That's fine. I'd rather PowerPoint breaks in my demo, so that's fine. There we go. So over the course of my career, when I've seen people talk about this, they generally go one of two ways. Either they go full in. This is going to be awesome. I am going to be the perfect developer. And then they fall flat on their face when reality hits them like a wet fish. Or they go totally the opposite way. It's like, we cannot do this. How can I write my tests if I don't know what I'm going to write? I'm not part of the testing team. I don't know fully what tests we're supposed to be doing. And the new one on the block, we have Copilot now. Why do I need to write tests? That can do it for me. I've heard all of this throughout my career, except the last one. Like I said, that's new, but I imagine that by the end of this year, it's definitely going to climb the charts. And not only have I heard most of these stories, I have used most of these comments as well. It's just because you see somebody standing up here does not mean that we are perfect. Far from it. So hi, I'm Stacy Cashmore. I have been writing software since the middle of the 1990s, and the further that goes on, the older I feel saying that. For the last 5 years, I've been Tech Explorer DevOps at Omniplan, a financial advice software company based in Amsterdam in the Netherlands. And since 2020, I still have to pinch myself that I get to call myself a Microsoft... New braces, I'm going to do this occasionally. A Microsoft MVP in developer technologies. Now, when we use these phrases, other things can happen inside of our code base. It's things we don't necessarily expect, and it's things that can make our life far worse. So I want to look at what happens when we can ignore this and then only implement technical tests about our code. Because you don't know, because you can't know what the functional tests are going to be. My experience has been that when this happens, your code leaves your developer machine. It gets thrown onto a doom pile for the tester. And while a team may have multiple developers, chances are you only have one tester. And that's if you're lucky. I have worked in multiple companies where you shared testers between the teams. This only makes it harder, of course. So the developers keep on throwing onto this doom pile, the tester gets more and more swamped, and eventually when they get to the story, they find issues. And they find an amount of issues. Not because we're bad developers, but because we have a different idea about what we're testing than they do. We each have our own interpretation. At this point, weeks down the line, we've got a context switch. We've got to get back into that previous mindset that we had before. Then we swear at the tester because they're testing things that we don't even think should be tested for this particular piece of code. And it goes backwards and forwards, and you get into this quagmire of discussions about, is this a bug? Is this a scope change? Is this a bug, but it's low priority? We're just going to put it on the backlog and forget it exists for the next 3 years. It gets to be difficult. Another scenario that I've seen is developers and testers do actually have a little bit of a discussion. They have a rough idea of what they're doing. They get the shared understanding, and then they start. Sounds better-ish. We start writing the code. And we have that plan to add tests as soon as we're done, because we know that we want tests. We're going to ask Copilot to write the test for us these days. AI, woohoo, time saved. Except, when you start down this path you can start to lose sight of the functional problem that you're solving because you get too deep into the technical problem you're solving. Something doesn't work and you get into that. I don't know if you've heard it about motorways. Motorways, you can fix all traffic jams with just one more lane. Always just one more lane. And it's the same with coding in this way. Just one more small code change and it's going to work. Just one more. And you go down this path and try lots of different things until something sticks. And at the end of it, you might have a pile of spaghetti that you think kind of works. It's no longer throwing errors anymore. And now what we need to do is write our test. And there the symptom really rears its head. Because all of a sudden, we find it really hard to write the tests against this code base. Either because, as an architect said to me in one of my jobs, which totally shocked me, we don't write tests here, our code base isn't suitable, which is code word for our code is just so hard to use, there's no way we can write tests against it. Or the other one that I saw quite a few people doing, they get to this point, we're going to write our test. What does our code actually do? And then they will just look at their code, they'll write a test, and when that bubble is red, they're going to keep on changing the test until the test goes green against the code that they've written. The actual code they wrote, that's never touched in this process. We're fairly sure that works. We don't want to touch that. It must be the test that's wrong. So now we either have no automated tests, or we have automated tests that include a number of bugs because we never bothered to actually check what our code was doing. And that leads me nicely into the last symptom that I want to talk about before we get on to solutions. And that is awkward tests. We have a code base. Somebody went out and installed Sonar Cloud. So we have 100% coverage. We're really happy here. Only a few of the tests, they fail for no reason. 25% of the time, 75% of the time. We all know that if that one pipeline fails, you just need to keep on running it until the test passes, it's fine. Or, even worse, they never fail. They always pass. And you may ask, well, why is your test always passing a bigger problem than them failing intermittently? Well, the first one, you no longer trust your test. If it fails, you just assume that it's failed because it's flaky and you keep on running it until it goes. It costs you time and it costs you context. Second one means you are putting bugs into production. Your users become your testers, and when they find it in production, that's when you start to panic. I've been there, I've done that, it's not fun. But both of these things, they create a common theme throughout the company. Developers get scared of changing code. The business gets scared of asking the developers to change code because they've seen too many production problems in order to move forward. Changing the code's hard, changing the tests, it's even worse. And then when we get back to the situation of, well, our tests are just such a nightmare, it's just not suitable. We stop writing them. Or because we have Sonar Cloud and we have to write them, we're going to game them to make sure that they always pass. Earlier on this year, I saw an app. I came back from long-term sick leave. I opened up the app and I looked at the code and thought, this is interesting. And then I looked at the tests and thought, what's going to happen if I start deleting stuff? And I am not exaggerating when I say I removed 80% of the code in that application. Basically, as long as it compiled, the test passed. So sometimes I removed entire classes. Sometimes I just removed all of the code from the classes and just made sure, like I say, as long as it compiles, the tests pass. And yet Sonar Cloud was saying, this is the best application in the world, 100% coverage, everything's fine. So let's look at some of the ways that we can try and help ourselves going forward here. And I want to start by acknowledging the elephant in the room, and that is confirmation bias. We all have it. We have it for multiple subjects, and this is certainly one of them. About 4 or 5 years ago, I went to a talk in the Netherlands by Scott Hanselman. And he started the talk with a comment which I'd never really considered before. Each and every one of you here today is in the top tier of developers because you are spending your time and your energy trying to improve your craft. Problem is, you're also in a bubble of lots of people that are putting effort and energy into trying to improve their craft. And we can kind of assume that this is real life. But actually, it's kind of a fantasy. Those first questions that I said, well, how can I test? I don't know what I'm going to write. I hear it from people at conferences. I hear it from other speakers. I hear it from colleagues that go to conferences. The thing is, we don't like admitting that we don't know things, and we don't like admitting when we have a problem. We will always try and find an excuse for it. That code base not suitable, that is this confirmation bias. It's not that the code is too hard. It's that our domain is just so complex, we can't possibly do that. So that is the very first thing in order to get into testing first, not just TDD, because I've heard so many people say you're giving a talk on TDD. I'm giving a talk on testing first. It's a little bit more than just the TDD. You have to accept that you are not infallible. It's really hard to admit to yourselves, but it's also the first thing you've got to do before you can move forward. Once we accept this, where do we start to actually improve ourselves? And well, we go back to the very beginning. I'm not going to start singing, although I desperately want to right now. Ask, what is the problem that we are trying to solve with this change? What, for the user, the end client, ourselves, improve when we implement this? Too often as developers, we get solutions given to us. And when that happens, you stop thinking about what you're trying to do and just think about implementing this solution. If I have time left at the end, somebody remind me. I've got a great story about that, but we'll see if it fits. But I did see this come from Roland on Blue Sky a couple of weeks ago, and I thought this was just a great example. From a large enough distance, every application just looks like a CRUD application. If the developers think it's a CRUD application, it tells you how far away they are sitting. So if you can get involved at the beginning, be that person that asks the question, what are we solving? What is going to improve with this? It helps you because your how, the actual solution, you can then map back to that why. And it helps you come up with a better solution. Very often developers will come up with a better solution than a product owner if they start to think what the developer should be doing. So you can go better here. It also means that when you've got your how, you can then do the back checks. Like, is this really what we need to be doing? And you can iterate and improve on yourselves. And secondly, testing. We actually come to the bit that the talk's supposed to be about. Your tests can now evolve around that functional knowledge that you have. You don't no longer need to test on the how my application is doing something. You can test on the why of your application. This does mean, shock, horror, we're going to have to talk to people. Testers, most definitely. Get to know your testers. I'm not going to say they don't bite, but most of the time they don't bite. Talk to your product owners, your business analysts. If you have the chance to, talk to your customers. They are a goldmine of information. And when you do this, you are going to learn so much more about your domain and your customers. And you're not only going to be able to make these technically awesome products, you're going to be able to make software that people are happy to use as well. No more of the other one I've heard, business to business. We don't need to think about the users. It's business to business. They don't matter. As somebody who uses business to business software, please, we matter. And so we want to have a good life as well. Downside here is your tester is no longer going to be the person responsible for making sure that all of your testing happens. They are going to be responsible for helping you make that solid testing plan, but as a whole team, you need to figure out how you're going to implement this. At this point, I get into arguments with some people about, I am a developer, it's not my job to test. Yeah, that. I swear at these people as well. One thing that I found that helps is switch from test to check. It's like you are checking that your software does what it's supposed to do, and you are checking that you've not inadvertently broke anything along the way. And that tester, what are they doing aside from helping make these awesome plans? They're not sitting twiddling their thumbs waiting for the next sprint. They get a chance to get on with real testing, to get into the code, to do all the stupid things that users do, and make sure that the application doesn't fall over in a way that nobody thought about before. They can do the exploratory testing, make sure we don't have surprises. When this works, you reduce your WIP, which reduces your stress. Your knowledge about your domain goes up, which improves your product, and hopefully you get to chill out and relax a little bit rather than stress every time it comes to doing a release. So they're the people skills that I think we need to change when we're doing this. But what about some technical things that we need to think about as well? Well, we now have our checks, and that gives us a huge boost because we can reduce that length of the pipeline to make sure what is going into the tester's pile works. I know so many testers that used to scream at developers with the, "Did you even bother running this? It fails on the first page." No, we have our checks. We can run through them. But we're also lazy because we're developers and we like to automate away work. So this is where you can automate your tests. And here we come back to the, but I don't know what I'm going to write. So how can I possibly write my tests? I know a quote from somebody I follow on Mastodon, Cheap or Hill. Can recommend following him. He's got some great nuggets of information. And he has a great answer to this question. If you don't know what code you're going to write for a test, how do you know what code you're going to write? And the answer to this is you're going to think with the keyboard. What I was saying earlier, you're going to do like one more change, one more change, one more change, lather, rinse, repeat until something works. Then we get to do our test and we write back to the beginning again of our code is not suitable or it's just too hard to do. The thing is, thinking with a keyboard isn't a bad thing in and of itself. It's a great way to explore your software, to look for your ideas and to get that inspiration. So what about if we join these two things up, testing first and thinking with the keyboard? And there, Cheap or Hill talks about microspikes. And that is a small, focused bit of code that does nothing more than exploring an idea of how you want to solve a bit of problem. This spike, it's not your final code. That means you don't need to write your test. You can do that whole thinking with the keyboard. All you're doing is checking if your idea has merit before you do it properly. How small is a microspike? The name micro, it's got to be tiny, right? A classic IT answer, it depends. It can be minutes, it can be hours. If you're into something that's really taxing your brain, it can be a day or so. To be honest, micro is a bit of a misnomer. The important thing to remember is that it's just a spike, it isn't your final code. So when it fails, don't fall into that sunken cost fallacy. Don't try and tweak it over and over. Accept that this didn't work, but it didn't work for these reasons. Get that knowledge from what you've done, reset your code, come up with a different idea, and try a second spike. And when it does work, awesome. Reset your code, which sounds really counterintuitive, and I know loads of people that balk at this point. But what you've got to remember is that this is not final code. You are deliberately thinking with the keyboard and just going with the flow. What you need to take out of this is a knowledge of how your final code is kind of going to look so that you can then write your tests and write your code to make those tests pass. The power of a microspike is that all you take away is knowledge, and all of that mess, you leave that behind with the reset. And back to people, don't think that this is solitary work. It can be. It doesn't have to be a group thing. But I have done this with testers. I've done this with product owners. I was even lucky enough to do it with some customers. We went round in circles for an afternoon once, and what we produced was absolutely spectacular. So if you get the chance to, iterate with these people. It's awesome. The downside, of course, we now don't have tests again. So you're doing your microspike deep inside code. It might be that you have a massively complex API. We had this for generating reports in our system. You had to go from here all the way through the code to here in order to generate the report. And that meant when we were testing these things, it could take 5-10 minutes to actually run a manual test to get the output. But we don't like hard work, remember? So why am I going to go through the user interface? The solution that I use here is a making app. This is also G. Paul Hill. I don't want to claim anything from him here. But basically, it's a small console application, Windows application, if that's your thing. And you hook it into the level that you are working on inside of your application. So for this report, we just hooked it directly into that report DLL, skipped everything else, and we could iterate really fast, and it allowed us to pinpoint the code that we were working on. Using this microspikes with making apps, I have managed to make some really incredibly complex applications in the past. That report was one of them. Making a DLL that can make PDFs, Word documents is super flexible, but in a way that we can test what we're doing. And doing that helped us reduce our technical debt for the future. We still have it in other places because, you know, we're human, but we managed to reduce it there. When you've got to this stage, there can be other things, though, that make your test really awkward. And that is when you have to know too much about what's going on inside of your API in order to test it sufficiently. If you step back and you reduce it to just the API, the inputs, the outputs, what happens inside, we don't care. 15 years ago, I think it was, I was at a tech days in the Netherlands, which doesn't exist in the Netherlands for over a decade now. And they were talking about dependency injection, passing the dependencies into the class so you can control what's going on from the outside. And when you're testing, you can replace all of these dependencies with mocks so that you can control really what's going inside of your class. I like this. I still use it. But there's always a but, right? Developers over the years have ran with this, and I think a little bit too far. It turned from injecting things where it made sense to being a dogma of you must never use the new keyword inside of a function. And it meant that now, rather than being able to control a class from the outside, I was now having to control everything in a class from the outside. But why should I need to know every little detail? I shouldn't do that. I cover up the mic. This makes our testing really hard because we can end up with setup code like this to set up every mock that we have in our test script. And most of these things, maybe we shouldn't know about. And once we get it, it makes it really easy to abuse these mocks and check what's happening with the mocks rather than what the actual API is doing. A mockery of a test. Thank you, Marat. That was an awesome one this morning. Breakfast conversations are the best. Now, I think you can actually help both of these things by just thinking about it when you're working on something. Make sure that the things you're injecting are really the things that you should be injecting, and you're not just doing it from that dogma point of view. Moving back to the API testing, for simple applications like the demo I'm going to do soon, it can be really easy. But in the real world, it gets complex fast. As I said, I write financial advice software, and our APIs are as complex as the financial rules governing them. They are huge, and they need to be huge because the amount of rules is just absolutely mind-blowing. Testing only our public API would be a nightmare. I had a colleague a few years ago, and he had seen Ian Cooper's talk on where TDD all went wrong, and look it up on YouTube. It's awesome. He's also speaking this week, so go see him. He said that we should only be testing APIs from the outside. So my colleague went, well, Ian says so, and he's just amazing. He is. So we have to get rid of all of our unit tests, and the only thing we should be doing is testing our HTTP API for any of our services. Anything else is a complete waste of time. And I thought, well, this doesn't make sense to me, because we would need thousands of tests per endpoint. An amount of those tests would be copied between endpoints if any financial rules were involved and any rule engines and anything like that. I don't want to write thousands of unit tests that are all going to turn red when something changes in the financial rules, which happens twice a year. 2022, I was at NDC in Oslo, and I managed to speak to Ian about it. And I said, is this really what you meant? Because I don't get it. And I'm really pleased to say that his answer was, well, you need to be pragmatic. Start at the outside. Great place to start. But when you find it gets difficult, you can move a layer in. And if it still gets difficult, you can go a further layer in. Basically, find the level that you need. But, and super important, you only ever test the user's API for the code that you are using. The thing that you need to remember is you might be the developer of the API and you might be the user of the API. So just make sure you are not looking at what's going inside, only at the inputs and outputs. This sounds simple. It can get seriously complex. I'm assuming we're in the UK, so people know the magic roundabout or have heard of it. When it fails, and it is going to fail because it's a learning process, don't get disheartened. This is where the pragmatism comes in, and you're going to have to learn over time. So that was a lot of me talking. I want to now show you this in action. And I'm going to show you a little real-life example. And by real life, I mean super simple, super contrived, to kind of show you the thought process of how you can go through this. So we have spoken with a user. And they need a simple way to write down tasks, check them off when they've completed them, and the ability to separate the view so that they can see what they've still got to do in the future. HTTPs let me add and remove tasks, and I don't want it to be complex, it's just a simple thing. We have a to-do app. It's kind of getting ubiquitous in conferences these days. It moved on from Hello World to to-dos. Now, we have a time and an interaction constraint here. So let's just assume that we've had all of the conversations with the user, and we're going to build the API. So, it brings us down to a to-do list for our to-do list. We need to get to-dos and get a single to-do. We need to post new to-dos. We need to put an updated to-do. And we need to delete a to-do. And I'll try to stop saying to-do. So let's get coding. So I am totally cheating here because it would take too long to type it out, and because I made too many typos in front of people to type it out. I'm going to be bringing snippets across, but I'll be explaining them as we go. First of all, I'm going to create an application. Can you read that at the back, by the way? Is that big enough? Awesome, thank you. We are going to use a .NET tool to spin up NO application, add a web API, add an XUnit, join them together and do some other cool stuff. And in the speaker room, this took like half a second. Now, I was going to say, I use the .NET command line here because it's an awful lot quicker than doing it inside of Visual Studio. So, of course, it's going to take longer now I'm actually on stage. But, seriously, have a play with the .NET CLI. Get out of Visual Studio. You can do awesome stuff with it, and it is super fast. So now we have this. We can open up our Visual Studio, which, of course, is going to open up on the wrong screen. And all I'm going to do here, I could add this to my script, actually. I'm going to delete my unit test because I don't want it. Now, before we start writing our test, there is some scaffolding code that we need to add so that we can get started. So we're going to do that now. First thing that we're going to do is make a record that handles our to-do. So this is a really cool trick, by the way. Rather than right-clicking and going through the menu, Shift F2, you can add new classes, and you can even put the whole folder name in there, and it will create your folders for you as well as your classes. Thank you to Jimmy Enstrom for teaching me that trick. So we're going to bring our record in. Yeah, it's really cool. I'm using a mouse and it slides down the table every time I start. Then we're going to make a repository to store our to-dos. And we're going to be doing this with an interface. Why an interface? Because it does make my testing simpler, and also because in every single company I've worked at, we did change database. And the ones where we had an interface, it wasn't easy, but it wasn't as hard. And the ones where we didn't have an interface, we gave up because it was just too difficult to do. So these are the functions that we're going to have inside of our to-do. Just to make it easy for myself, I've just commented them out for now. And now we can add our repository. It's going to be an in-memory repository because I don't want to talk to a database here. In real life, obviously, this will be talking to the database, and I will be using this in-memory repository inside of my tests. We'll get to that one. And yeah, I'm just storing everything in a to-do list. And last but not least, I want to make some changes to my program CS. And what I've done here is added the singleton to the in-mem database. I've added an endpoint for the to-dos. And this code down here, I need for my tests. I'm going to use a web application factory, and that does not like top-level statements. So you need to add this at the end of your program so that it can actually find your program to use. So let's make our first test. We're going to add a test to our to-do app, to our testing project. And we do need a little bit of setup here because we are going to use a, why are you should work. Why are you not picking up the things? Did I put this in the wrong place? No.
Using statements or package support.
Why do you not? I added MVC testing to this. Was there? I should have really been looking for that, shouldn't I? Oh, you know what? Whenever things go bad, what we can do is close our Visual Studio. Sorry? I've got to use that in one of my demos at some point. Where are we? Do we have it in temp? Shall we try that one again? See, this is where it gets interesting because I've got to add a bit of code again now. You know what? The first thing I'm going to do is just check that my test works before I go further. I have different layers of backups for this. Let's come in here. You know what? We're just going to reuse that unit one. Right, MVC testing works. Cool. We can make this work. Just give me 2 seconds and I will get all of this working as we need to. So we're going to bring in our record again. We're going to bring that across. Then we're going to bring in our repository. Whoops. Yep. Then we can do the, you know what? I have done so many run-throughs for this, and this is the first time it's not worked. Because it always fails to work at the point where you really, really need it to. And I think any speaker can tell you that that's always the way. Right, do you now build? You're still not building. Why are you not building?
Have a reference from the API.
In theory, I do. Okay, that makes sense. So, no idea what went wrong there, but we're getting there. We are spinning up a web application factory for our program. That allows us to pass HTTP requests into it and test inside of our app, inside of our unit tests. I am going through and removing the to-do repository because I want to add my own to-do repository, which is going to be a mem repo, which doesn't exist yet. So let's add that one next. And like I say, in real life, this would actually be the whole in-memory testing. For now, what I'm doing is just extending it and adding one extra function on the end, which just allows me to remove everything in my database so I can keep my tests clean. I'm going to assume in real life you don't have an option on your database class to just delete the whole database. And that'd be fun if you do. Being the developer that deletes production. So now that we have our test ready, where's my unit test 1? Let's write our first test. And the thing to do here is to start as simple as possible. I have an empty database. I want to get a list of to-dos. It's going to be empty. So I expect to get an empty list back when I do a call to my to-dos. We're going to run this. It's going to fail, of course, because we want to see red before we see green. And if everything has gone to plan, it's going to fail for HTTP response status, because, of course, we're getting a 404 rather than a list of empty to-dos. So now let's fix it. We're going to add our endpoint. So inside of our program CS, we need to update our repository. So let's undo the get all here. And then, of course, we need to actually return the code inside of our repository. Now, when we run our tests again, obviously, it should be green. This is a nice, simple test just to get us into it, and it went green. That's a nice, easy test to get us into what we're doing. Next thing that we want to do is expand it a little bit. What happens if I actually want to make sure I get something back that I know is in my database? This is a point where I've seen so many mocked tests fail because they just mocked everything so that you always got a response back. And that was one of those tests. You could do what you like in the code. It would always pass because of their mocks. So we're going to do something different here. Because we have that in-memory storage, we're going to do everything through the API. We only care about the inputs and the outputs. So we're going to make a to-do. We are then going to post that to-do to our API. Then we're going to get the response. And then we're going to do a test to make sure that it succeeded, that we only had one, and that the to-do that we got out matches the to-do that we put in. So I'm using a fake here, but I'm not mocking anything. The API has to run as it would run. We get a red test, of course, because we don't have any code there to make it work. So now we're going to add our add functionality. Because to make this get functionality work, we actually need to be able to add something. Fun one is, if we do this, we don't actually need a test explicitly to say, can we add something? Because this test will work for that one. So we need to a simple add here. And then in the program, I am going to cheat now. And this is where doing this does come hard. I'm curious if you see all the places I'm cheating. I'm not going to tell you all of them. I want to add a to-do, and then I want to return a created at root. But in order to make that work, I actually need to get that route set up in my code. Otherwise, it won't compile. But I don't have a test for this yet. I'm actually cheating. Now, making sure that I just throw an exception if this is called, but it's still cheating. I should really do this in multiple steps, but it's also one of the pragmatism things that you'll find when you start working with it. Now we should get working code. Yes. And again, we can move on. And what I want to move on with, I've now got not implemented exception. I don't want that in my code, so I'm now going to check this one as well. So we're going to add another unit test. And this is going to look reasonably similar to the last one, because I'm making a to-do and I'm posting it. But now I'm getting that individual to-do back, making sure it's successful, and then just making sure that it's not null and it matches the one that I've posted. So all the time, inputs, outputs, making sure you're getting what you expect to get. So we're going to run this one. It's going to fail again, of course. And then we can fix it. So now we need to add our get by ID. And then we can get what we're looking for and then make the API for it. So I can get rid of my not implemented exception here. And what I'm going to do is I'm going to get by ID. If it's null, I'm going to return a not found. If it has something, I'm going to return an OK. Do you see the cheat? I've just added code that I have no test for. This should not be here. I have no way of knowing if this is going to work because I have no test set up in order to find this. So again, pragmatism, think what you're going to be doing. Nothing is 100% and nothing is ever as simple, even in a simple example. So now we have that. We should hopefully be able to run this and see it working again. Yes. Next up, the user wants to be able to update their to-dos because they want to be able to check them off. So we're going to add that test next. And you're getting the idea here. We are going to make to-do. We're going to add the to-do. And then we're going to call our put to update it. Then we're going to get the to-do after we put it. And we are going to check that it equals the updated to-do and not the original to-do. And we're going to run that, and it's going to fail. Thank you. We're going to add our endpoint in here. And you'll see the other cheat here, because again, I'm saying if it doesn't exist, return a not found. But I still have no test for this. So in the real world, this would be more expanded than it is, shall we say. And then, of course, we need to update the repository. We're nearly there for the simple stuff. And this should obviously work now. Should. Last one, we want to delete our to-dos. You know the drill by now. We're going to add a test. We're going to make the test fail. The fun thing is these tests are obviously going to fail because the endpoints don't exist. But as you get into a bigger application, you'll find the other reasons why it's failing. And you're going to build it up in a more realistic way. So we're going to map our endpoint. This is where I have interesting conversations with people. What do you do, aside from cheating, what do you do if you can't find something you're deleting? I know half the people I argue with say it should return a 404 because it's not found, and half the people say it should return no content because it's supposed to be idempotent. I want to delete something. If it doesn't exist, I'm happy. I don't need to know it was already deleted previously. I know which one I prefer. I don't care which one you prefer. It's not a fence I'm prepared to die on. Do what works for you.
But do the second one.
Awesome. I like it when people agree. It puts me in a bubble. Okay, so now we need to give our delete. And then, of course, we need to implement the delete. And then all of our tests should pass. And that is our application. We build it up, test at a time, gone forward, and all those little balls are green, and I made it go green with the code, not with the tests. Now, our users have been using this for a while, and they love it, but they have an issue. They're a little bit forgetful. They're me. They keep on writing new to-dos which already exist in their to-do list. Thankfully, because they have a brain like mine, they always do exactly the same description on their to-dos because, it's contrived and all that. And they want to make sure that they get information when they are adding things that already exist. So we're going to do a last test, a functional change now that we've been using it for some months. And we're going to make sure that if you call post twice, that we get a conflict back. And again, doing this with mocks is just so easy to say, if you call this, give me back this thing inside of your whatever layer. Doing it this way, we can actually check that the repository layer we don't particularly care about, but that the code actually works in the way that it should do. So this is obviously going to fail again. And now we need to make some changes. We're going to change the way our add works in our repository. So we're going to go from a really simple add to do. And instead, we're going to check, does this exist? If it does exist, throw an invalid operation. Otherwise, just carry on as normal. And then our post also needs to take this into account. So if I can find my post, I always get lost at this point. It's a little bit more complicated now because we're going to be inside of that try-catch block. We're going to make sure that we can catch an invalid exception and return a conflict. So we should now get green balls. I could have also done this inside of my API.
I don't want green balls.
This is going onto YouTube at some point. Thank you. I could have done this directly in the API, and it wouldn't have mattered for my test. I could have just called my repository and say, does this exist? And throw the exception myself here. It doesn't actually matter where you are. I'll get you back for this. Right, the last thing that I want to show you in the code is refactoring. When you have awkward tests, refactoring is the worst thing in the world because you change one small thing and everything explodes. Even though you know that your functionality is the same, all of your tests fail. And that makes you either afraid to refactor and improve your code, or it just means that it's going to take so long that that's when the business comes in with, why are you refactoring everything all of the time? We don't have 3 weeks for this. Stop trying to gold plate everything. I hate it when companies say that. I argue with them every time. So we're going to do some refactoring here. In fact, we're going to completely rewrite this repository. What I'm going to do is replace this list with a dictionary instead, which gives me lots of red squiggles on my code. So in order to fix that, I'm going to delete all of this code. Is that everything? Come on. Yeah, that's everything. So let's delete all of this and paste in a whole new repository, which works in completely different ways. We are calling different functions in order to actually do the storage of what we're doing. We are using different if statements. It is different code. And when I run my tests, please, you can do it, little computer. everything's green again. Because I'm only testing that input and output, I can do what I like to my code, and I know if I'm going to upset my users or not. I think that last one for me, that is a bit that I love about testing in this way, because when I spot a problem, I can actually try and solve it without being too afraid of what's going to go wrong 2 months down the line with something that a user suddenly hits. Last thing, I think I'm just about on time. I want to show you the making app that G4 Hill talked about. Now, do you need a making app for this application? Absolutely not. But I want to show you the idea anyway. So I already had the making app because I had to open up my first level of backup. I do need still to add the project reference. So we want that one. Think of the making app as a scratch pad that you're working with. So here I'm talking directly to the repository. And this is really useful when you are writing against things like infrastructure as well, because I don't particularly want to talk to Cosmos DB every time I do a unit test. I have an interface for that, and I'll replace that interface. But when I'm coding that Cosmos DB interface, I do actually want to play with it and see what happens. And that is one of the things that I really use this making app for. You just spin up the repository, and then you just interact with it directly. This is not production code. This is your thinking with the keyboard, scratch pad, what happens in this situation, quickly make it, and then run the code. So what we're doing here is just adding a to-do, updating it, and deleting it, and checking what happens every time it comes out. And of course, that's on the wrong side as well. So literally, I just have this output that I'm working with. Get to do, this is the to do that we just added. Get the updated to do, this is what we did the next one. Get me to the deleted to do, doesn't exist. And it just allows me to iterate super quickly without going through the rest of the things. I lied. I have one more thing that I want to show you in code before I go back to the presentation. Yeah, still on time. Dry code, damp code, wet code. We've all had it hammered into us. Don't repeat yourself. Everything has to be dry. Personally, I think that's bad advice anyway. There's always, it depends whenever you're doing things. I'll give you an example of this. We like to use the idea of duck typing for when we should abstract things. If it looks like a duck, quacks like a duck, and something else like a duck, it's a duck. Except if it's a robot and it takes batteries. Because I'm fairly sure you don't want to be throwing your robot in the pool, and I'm fairly sure you don't want to put batteries in your duck. So at that point, it wouldn't work. So I personally think dry, it is an awesome guideline, but don't use it dogmatically. When it comes to testing, it's even more important not to get drawn into that. Everything has to be abstracted away to the detriment of your tests. So let's have a look at our tests. Let's get rid of everything else. Close up the tabs. We have an amount of repeated code in our test. And there's some stuff I want to keep, and there's some stuff I don't. Obviously, this is needed for every test, but I don't want it in my test setup. So I don't mind moving that back up to the beginning. Then when I have my tests, this one's fairly simple. That doesn't have anything. But here we have this making a to-do and posting a to-do. And we have this assertion at the end. And here again, we have this making and posting. And that actually carries on down. And we have the assertion all the time. I do want to clean some of this up, but I don't want to clean all of it up. What I don't want to clean up is the setup code. And the reason why I don't want to clean the setup code is because this is important to my understanding of what my test is doing. I don't want that hidden away. This allows me to read through it and get a really quick idea what I'm doing here. The other issue is, I've seen it, by the way, with tests that were actually an absolute mockery, and it was abstracted to like 3 base classes. And in order to see what your test was doing, you had to hold all of these different classes in your head. And again, everybody was scared of changing those tests because nobody knew what they were doing. So this I want to leave as is. The other reason I want to leave it as is because this is my duck. I'm always adding the same to-do, and I'm always posting it. What happens if I have a test where I want to do different things that kind of look similar, but I've already abstracted all this away? Okay, I just need to change this test code or this test setup, which is abstracted away, and then my test is going to be easy to write. And all of a sudden, all the other tests fail for no reason, and nobody knows why. I think this is really specific, so I want to leave this. What I do want to get rid of is we are just checking a to-do here, and I actually think that is a reasonable thing. You can disagree. Again, not going to argue. This is something you're going to get when you try it and fail, or try it and it succeeds. This is the trial and error part. But I think that I can change this to a function. So let's come down here. I want a check to do. And actually, check to do is not a nice name for this. So check expected to do matches, I don't know, input to do, something like that. That's possibly a better name. But I am happy to use that in places like this, because I think that the name is descriptive enough that we know what we are doing to make sure that our to-dos match. So we can check that and... Oh, come on. This is a point where I was going to say, and this is where AI does actually help you in writing your tests, and Copilot's decided to disappear on me. So what do we want? We want fetched to do. Oh, there we go. Thank you, to do. So now we can replace these, and I think this actually helps our code. You're really not going to do it. You're going to make me work, aren't you? Yeah, and this is, like I say, I just think this is more readable and more explanation about what we're doing. So we'll change the last one. Run our tests. It would probably be better if I used refactoring tools in order to do this rather than just like injected it, but... Ooh, it failed. Why did you fail? What am I doing wrong? Updated. Thank you. Is that the right one? You get the idea if it still fails. There we go, it works now. So, come on. Thank you. I think we can all agree that this was a really simple, contrived, not real-world specific example. But I hope it's still giving you the insight into how you can get started and start experiments and getting out of that bubble trap. But like I say, whilst this was a really simple pointless example, I have used this in the real world to make several complicated applications. The report that I was talking about, I figured out what the users needed from my DLL. I wrote the tests in order to match that, and then I wrote a making app to allow myself to experiment going forwards before getting all of my tests to go green. Also used it in a different way. Whilst the interface allowed our developers to check what data they were putting into report and to check what should come out of it, you don't want to be testing Word documents and PDFs in a unit test, because even if you capture one and try and compare it, you're going to have time date differences and all sorts of stuff that makes it a nightmare. So what they started to do is we used the Making app to use their data to manually create this PDF without having to go through and fill in a whole financial dossier. Oh yeah, that looks good. Our unit tests for our report match what we're putting into that. We're like 99% sure that's going to work. So we can now push it to production and we can double check it. It helped tremendously. I do hate having to say the last few things that I've got to say, and that is getting this working 100%, being the most perfect developer in the world, is an absolute pipe dream. It is not going to happen, and it's not going to happen for your team. Some of that is down to existing code bases. If you're in a greenfield site, it's so much easier. If you're not, it's harder. I did this for part of one of our applications. And it took me more than 3 weeks to do the refactoring and rewriting and get all of the planets in alignment to get this whole thing to work. I am really lucky in that my role gave me the chance to do that. I was allowed to spend the time doing this to make other people's lives better. I am well aware that there is literally not another person in the company that could have done this without having management breathing down their necks. And I appreciate it's something that in a lot of companies you can't do. So you are going to have to pick and choose where you start. And remember, this is a journey, not a destination. The journey is going to teach you way more than the destination will, because the thing that the destination should teach you is there's a new horizon out there, and you start again and learn new things. And like most journeys, not an easy one. You're going to fail. You're going to have false starts, frustration along the way. But I personally find that whilst it is difficult to get into, once you get there, it's a whole lot more enjoyable to actually work this way and into the future. I've been Stacy Cashmore. Thank you so much for spending this time with me. I'm super stoked. I was expecting an empty room with everybody watching Richard. So yeah, enjoy the rest of the conference.